We did that a little bit last lesson when we were using our place value to help us do that. So converting decimals to fractions can be done by expressing the number as the numerator. So that means the numbers that are after the decimal point are going to go on top of our fraction to make our numerator. And the place value of the smallest digit becomes our denominator. So that is what we were doing last lesson, and I'll give you a quick little example as a recap. If I gave you the decimal 0.2, the 2 is in the tenths position, so the 2 goes on the top, and because they're tenths, the 10 goes on the bottom. Okay, that's what we were doing last lesson. It was just a bit wordy there, trying to explain what we did. So here's another example. 0.25 becomes the 25 over 100 because the 5 is in the hundredths position. Okay? This, of course, can be simplified though. The ones we were doing yesterday, we didn't simplify. Today we're going to go the extra step further and simplify the fractions. Converting fractions to decimals can be done by dividing the numerator by the denominator. So for example, 37 over 100 can be easily written by moving the decimal point and using the place value to give us the 0.37. However, something like 5 over 8 is not quite so easy to do. We don't have an 8th position in our place value chart. So what we're going to be doing is we're going to be using our calculators to type in, and see my fancy new calculator, it looks more like yours. And it's bigger.
Oh, it isn't?
Yeah, it is. Oh, it's bigger than the one I was using the other day. So I type in my fraction 5 over 8. And to make that into a decimal, you just press that SD button. So you get the 0.625. You can also use the divide button. If you go 5 divided by 8 instead of the fraction line, it will give you the same thing. We're also going to be doing recurring decimals. Recurring decimals are decimals... Recurring decimals are decimals with a repeated pattern. So we're going to use dots or bar above the numbers to indicate what is being repeated, or to indicate the repeated pattern. This last word is pattern. So here's an example, few examples here of recurring decimals. 1 over 3, that's the fraction. If you to put that into your calculator and make it give you the decimal, you get 0.333333333, and it will just keep going forever. To write that down, we simply put the number that is repeating, so 0.3, and we put a dot above it to say that that is going to repeat over and over and over again. 13 over 11 is 1.181818. So I write the 1 point, and the 18 is repeating over and over and over again. Now you have a choice. You can either put dots above both of the numbers that are repeating, but normally when there's more than one number repeating, we choose to go to the other option, which is to put a bar across all the numbers that are repeating. So that one had 2 numbers repeating, so above the 2 numbers repeating. But in the last example there, we have 1.71428571482885. Do you see the repeat? It goes for quite a few digits there. So you've got the 7 here, and then when it gets to the next 7, it starts repeating the same pattern again. So it's 1, 2, 3, 4, 5, 6 digits that are repeating. We have to write them all down once 1.714285, and we just put a bar across the top of all of those 6 decimal places to say that they are going to keep repeating. Yeah, hang on. You're all right? Okay. So examples. There's a few here, but they should be nice and quick because we're going to be using our calculator mostly. For the first one, I'm just going to do a quick recap for those who like to do things without calculators. If I have 0.2, the 2 is in the tens position. So without a calculator, I would put the 2 on the top and I would put 10 on the bottom. However, we want to go the extra step, like I said today, which is to simplify it. And I can divide the top and the bottom by 2. So I go divide the 2, divide the 2. Got to do the same thing to the top and the bottom. 2 divided by 2 is 1, and 10 divided by 2 is 5. Okay, that's doing it without a calculator. And you can see that some of the decimals here, that would be 352 over 1,000. That's going to be pretty big numbers to try and simplify. So this is where we're really grateful to have our calculators. So for the other ones, let's do B. We just have to type in 0.45 and press equals. Okay, it's still a decimal when I press equals. So I press the SD button and it puts it back into a fraction for me. That's it. Yep, it will simplify it for you.
And how would you do without the calculator?
Without the calculator, we would do it like we did in A. So I'll do that on the side for you, Daniel. We've got 45. The 5 is in the hundredths position, so that would be over 100. And then I need to work out what I'm going to divide by. So both of those numbers could divide by 5. 45 divided by 5 goes 9 times, and 100 divided by 5 goes 20. So you can do it, it's just a bit longer process. Let's do C, or have you already done C, some of you? Type in that decimal, press the equals, and press that SD button. Ferris, in a minute. So 44 over 125. Let's keep going. D, 0.07. Press equals and press the SD button. So that one was an easy one that we could have done without the calculator because it was 7 in the hundredths position and it doesn't simplify at all. E, we have 0.056, press equals and press that SD button. That SD button is going to be very popular in this topic. 7 over 125.
Do you have to do like a 0 point?
If you just do the point and then 0, that's okay. It'll still do it right.
But I suppose if it's like an actual number.
Then you have to type it, yes. F works when there's a whole number out the front as well. So 2.5, press the equals. That's also an easy one you could do on your calculator. The calculator always will give you the improper fraction. Do you remember how to make it do a mixed numeral?
Yeah.
Anyone? Yes, Stella?
You put the 2.
Oh, that's how you do it. How do you make the calculator do it? Poppy. Ooh, which buttons do you press? Anyone remember which buttons to press to make a calculator do the mixed numeral? Yes? Camilla? Shift and then the SD button.
Where's the shift?
Shift is this one up here. Shift and then the SD button. So that will make, and again, that one was a pretty easy one to do in our heads because 0.5 is a half, isn't it? So 2.5. Next one, 6.45. Press the equals. SD turns it into improper. So I'm going to have to go Shift SD for my mixed numeral. 6 and 9 over 20.
Do you have to put it in the
Yeah, you should. And one more, 10.35 equals, and then Shift SD to turn it into the mixed numeral. Okay, so that is going from decimals to fractions. And question 2 wants us to go the other way. It says convert these fractions to decimal. Guess what? The calculator is still going to help us here. But let's do a couple of them without the calculator because we know we can. So the first one, A, 7 over 10. Because it's over 10, that's telling you that that 7's got to go in the 10th position, which means 0.7. We didn't need a calculator for that. All right, how about B? We've got a 4 over 10. So the 4 is in the 10th position, so 0.4. Easy, right? So C, 36 over 100. So the 6, the last digit has to go into the hundredths position, which is 0.36. D, 13 is over 100. So the 3, again, goes into the hundredths position. So 0.13. So the 1 is in the tenths, the 3 is in the hundredths. E, be careful with this. The 3 is over 100. So it's got to be in the hundredths position, which means there's nothing in the tenths. I'll need a 0 there for the tenths, and the 3 goes in the hundredths spot. Everyone knows what I'm talking about with the tenths and the hundredths? Remember place values from yesterday?
Yeah.
Okay, F, a bigger fraction, but still works. It's over 1,000. So the 7 goes in the thousandths position, so 0.457. Once the denominators are no longer a 10, 100 or 1,000, to do it without the calculator, you would have to make them out of 10. So for example, if I was going to do F, I would say I can times both the top and the bottom of that fraction by 2. That's right. If I times by 2, I'm going to get a 4 on the top and a 10 on the bottom. Now that they are tenths, I know that the 4 goes into the tenths position, and there it is as a decimal. Okay, let's try another one like that. So the 3 over 20. I'm not going to get to 10. We're always going to make it bigger. So I want to go to 100. What should I times by? Not 4. 5. Times, you can do little times by things on there. That's a little reminder on how to do it. 3 times 5 is 15. And 20 times 5 makes 100. Once it's over 100, I put the 5 in the hundredths position, so 0.15. Now, I did promise we would do some of these with the calculator. So H. Typing those in your calculator to do it, you use your fraction button, 11 on the top and 50 on the bottom. Press the equals, and there it still is as a fraction, and we just press that SD button to make it turn into a decimal, so 0.22. Okay, so even though 7 over 10 is going to be a really easy one, let's try that again. Fraction button, 7 on the top, 10 on the bottom, and press that SD button, 0.7. Now, this is going to be especially important for J, K, and L, because these ones don't go nicely. You're not going to be able to times 3 by anything nice and get that to turn into 10, are you? 3 times doesn't work. So these ones are going to be your recurring decimals. So what we really need our calculator for this. We're going to type in 1 over 3 equals, press that SD button, and there's that recurring decimal, 0.33333. So we know how to write that. 0.3, and the 3 is repeating, so we put a dot above it. Okay, let's do it again. Type the fraction in, 1 over 6, press equals, and press that SD. Now your calculator will always round the last digit, which is why my last number is a 7, because 6s round up to be one bigger, right? So it actually is 0.1, and then the 6 repeats the whole time. So you need the 0.1, but only put a dot above the 6, not the 1. The 1 wasn't repeating, only the 6 was. The one that's repeating, yeah. L, last one, typing in 2 over 7, pressing equals, and my SD button. So I had 285714, 2857, so it started the pattern again, didn't it? Can you see the pattern there? Starting with 2, and then the 2 again partway through on the calculator. So it's 0.2857 2, 8, 5, 7, 1, 4. And then on your calculator it starts again. 2, 8, 5, 7, 1, 4. So that's going to repeat. It doesn't have enough places to keep going, so that's why it stops. Daniel.
How would you do that without a calculator?
Aha! Yes! I was thinking maybe to offer that as a bit of a challenge to see if anyone could do it. Or do you want me to show you?
Yeah. Could you show us first? Because I'd like to know.
I'll show you an easy one.
Okay.
And then if anyone can get L, maybe I will give you a lolly or something. All right, let's do J. If I had to do this without a calculator, I need to divide, remember your good old divide sign. I want to divide 1 by 6. Now, obviously 1 doesn't divide by 6. So what we do is we put a decimal point and we put some zeros down here so that we can carry things over into the next column. So 1 divided by 6 is not going to go. I'm going to put a 0 up there because that doesn't work. And I move my 1 into the next column, making it a 10. 10, why did I do 6? I'm doing the one underneath. I'm doing that one. Sorry, I'm doing that one. 10 divided by 6 goes once. And my remainder is 4. Good. Put it on the next column. 40 divided by 6 goes 6, because 6 is a 36. And then I have a remainder 4 again. And so that's going to just keep happening. I'm going to get 6 remainder 4, 6 remainder 4. And as soon as I realise that that pattern's going to keep going, I've got my recurring decimal, 0.166666, so on. Yeah. All right. If anyone wants to have a go of doing without the calculator for L, let me know if you've got that. I'd love to see it.
Can you go through the first